This is AP Physics, homework 3.2, question number 3. A 43.4 kilogram crate is at rest on a level floor and the coefficient of kinetic friction is 0.414. The acceleration of gravity is 9.8 meters per second squared. If the crate is pushed horizontally with a force of 325.753 newtons, how far does it move in 5.48 seconds? So I know that it is initially at rest, so I know my initial velocity is 0. I know I have 5.48 seconds, so my time is 5.48 seconds. It says how far does it move, so I'm looking for an x equals something or other. Gee, if only I knew my acceleration, then I could use one of my equations of motion to solve for my distance. Well, I'm going to get my acceleration by using my forces here, because I know that my acceleration is going to be my net force divided by my mass. So now I've got to look at my free body diagram. Here's my crate. It's at rest on a level floor. The coefficient of kinetic friction is 0.414. I'll use that in a minute. It's 43.4 kilograms. So all of my forces here, I've got a force of gravity. I've got a normal force. I've got a push force. And I've got a force of friction. Now, your first instinct might be, oh, look, they're all balanced. But wait a second, this thing is accelerating. So if it's going to be accelerating, it's going to be moving, and it starts at rest, then there's no reason to think that force push and force friction are going to be the same. I know my force push, and in my case, that is going to be 325.753 newtons, a very detailed number, but I'll go with it. I need my force of friction. Well, the only way to get my force of friction in this case is that my force of friction is going to be my coefficient of friction times my normal force. Well, I don't know my normal force either, but I do know my gravitational force is going to be the mass times the acceleration of gravity. So that's going to be 43.4 is my mass here times my 9.8. So that will give me my force of gravity. And mu times the normal force, and the gravity force is going to equal the normal force because there's no other forces up and down, and this isn't going to accelerate up and down. So I know that my force of gravity equals my normal force. So now my force of friction is going to be mu times the normal force, and the normal force is 43.4 times 9.8. So now I will know my force of friction. Well, my force of friction is to the left, and my push is to the right. The difference between those two is going to be my net force. So my net force is going to be my F push minus my force of friction, because one is one way, one is the other way. So I'm going to figure out the magnitude of my net force. And then my acceleration is going to be my net force divided by my mass, and my mass is in kilograms, 43.4 kilograms. So now I know my acceleration, and my acceleration gets plugged in here. And now I've got to figure out a distance with an acceleration, an initial velocity, and a time. I know that my position could be my initial velocity times time plus 1/2 my acceleration times time squared. My initial velocity is 0, so that goes away. So now I just need my acceleration from this part and my time here, and I will solve my problem. And that is going to be the distance that it moves.